In this video, we're going to do some practice problems that use the multiplication rule, permutations, and combinations. So in the previous video, we saw that the number of ways to select k objects from n objects depends on whether order matters and whether repeats are allowed. So if order matters and repeats are allowed, then there are n to the k ways for this to occur. And this is just using the multiplication rule that, for the first element, if order matters, there are n possibilities for the first element, and there are n possibilities still for the second element because repeats are allowed, and there are n for the next down to the last element. So we have picked k elements, and there were n choices for each because of the multiplication rule, and that's and. There's n choices for the first and n choices for the second, and so on. That means there's n multiplied by itself k times. In other words, n to the k ways to select these k objects. If order matters but there are no repeats, then we have a permutation. So because there are no repeats allowed, there are n choices for the first object and n minus 1 choices for the next. We've selected one, and n minus 2 for the next, all the way down to the last object that we pick. The last object that we pick is n minus k plus 1 because we are only selecting the first k objects. We're not selecting the remaining of them. This is also equal to that formula you see above, n factorial over n minus k factorial. Lastly, if order doesn't matter and there are still no repeats, then we take what we had previously for npk. That's the number of ways to select k objects from n objects where order matters and there are no repeats. And then we divide out by the number of ways to reorder those k objects. So those are our three formulas, and let's look at a couple examples to see how to apply those. So here is just a bunch of practice problems. 1, 2, 3, 4, 5, 6 practice problems to try. So grab some paper, think about these problems, think about which of the formulas above apply in each case, and we will try those together. Okay, a gym class of 20 students is selecting 4 students for a volleyball team, and that volleyball team has no positions assigned. In how many ways can these players be selected? So you should think to yourself automatically, are repeats going to be allowed? Can a person be chosen more than once to fill a position? And does order matter? So here, we're selecting 4 people. We wouldn't want to select a person twice because then we really only have 3 people. So no, there are no repeats allowed. Does order matter? There are no positions being chosen for this volleyball team, so no, order doesn't matter. And that means that this is a combination. So this is a combination. This is 20 choose 4, or that's also written as 20 choose 4. And so that is 20 factorial over 20 minus 4 factorial, the number of ways to select 4 students in order, and then dividing by 4 factorial, the number of ways to rearrange those 4 students. We could do this with a calculator or a computational device if yours has a factorial. If it doesn't, you can also Google combination calculator for these because some of them are pretty large. This one we can do by hand, so let's do it just as practice of simplifying combinations. So 20 factorial is 20 times 19 times 18 times 17 times 16 times ... On the bottom, 20 minus 4, that's 16 factorial, 16 times 15 times blah, 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 times 4 factorial, 4 times 3 times 2 times 1. I didn't bother writing out all the rest of the factorial because a lot of it cancels. So 16 factorial cancels with a lot of 20 factorial. And so we've got this left. We could do some more cancellation. For example, let's see. We've got 4 could cancel with sum of 20, leaving 5. So 4 is canceled. 3 and 2 could cancel out with sum of 18, leaving 3 left, canceling out the 6 from that. And so it's still like not the most nice thing to multiply, but at least if you don't have a factorial button on your calculator, now you can just multiply 5 times 19 times 3, and if you do so, you will get 4,845. Okay, great. You could also, again, do that with a computational device. Next, a gym class of 20 students is selecting 9 people for a baseball team with positions, so catcher and first base and so on. In how many ways can these players be selected? Now, again, we're asking ourselves 2 big questions. Are repeats allowed? And does the order in which the objects or the players, does the order matter? So repeats, again, no, you don't want the same person being both first base and catcher or something. And does the order in which the people are chosen matter? Yes. So it's a different situation if, Alan is chosen for first base person and George is chosen for catcher. That is a different selection being made. So there are no repeats allowed, but order does matter. This then is a permutation. So this is a permutation, and this is 20p9, 20 permute 9. So that's 20 factorial over 20 minus 9 factorial. That's 20 factorial over 11 factorial. And you can, of course, do this by hand, but it's easier to use some kind of device. And you get quite a large number. That is, that is 60 billion, 949,324,800. So there's quite a lot of ways to do this. You could also do this just using the multiplication rule, and the multiplication rule would tell you that there's 20 possibilities for the first position chosen, and 19 for the next position chosen, and 18 for the next, and 17 for the next, and 16 for the next. 1, 2, 3, 4, 5. We need 9 positions altogether. 6, 7, 8, 9. This is another way of doing this, and it is equal to what we have over there, just using the multiplication rule. Next, we've got 4 friends buying ice cream, and there are 12 flavors available. If they each get 1 flavor, how many ways are there for them to buy this ice cream? And we are assuming that it's a different way, or a different it counts as a different thing. If Aaron gets chocolate and Bernice gets strawberry, that's different than the reverse. So again, our questions are: does order matter, and are repeats allowed? So order, yes, order matters here. We're saying that who gets what matters, not just the flavors ordered. And are repeats allowed? Well, it doesn't say that they're not. So it could be the case that everybody gets strawberry. So yes, we could have repeated flavors here. So the number of ways for this to occur, we could think of this as, what does Aaron get? What does Bernice get? What does Carly get? And what does Dwayne get? And so there are, how many choices for Aaron? There are 12 possible flavors for him to choose from. For Bernice, there are still 12. She could get the same one or a different one. For Carly, there are 12 flavors, and for Dwayne, there are 12 flavors. So this is using the multiplication rule. And so this is 12 to the 4th is the number of ways that this can occur. If we multiply that out, we get 20,736 different ways that they could buy this ice cream. All right, what if we change it a little bit? We say that no 2 of the friends get the same flavor. So if that's the case, then does the order matter? Yes, still the order matters. Are repeats allowed in this scenario? No. We're saying that nobody gets the same flavor. So once one person gets strawberry, nobody else is getting strawberry. So again, we've got, what does Aaron get? What does Bernice get? What does Carly get? And what does Dwayne get? And so there are 12 choices first. Now one of them is selected and nobody's getting the same, so 11 next, then 10, and then 9. And so altogether, this is 11,880. If we multiply it out, this is the same as 12 permute 4, the number of ways to select 4 objects from 12 objects where order matters but repeats are not allowed. Okay, how many subsets of size 4 does a set with 10 elements have? These are subsets, so order doesn't matter. The order of a set doesn't matter. And can we repeat elements? No. A set can't have the same element twice, or if we add the same element into a set, we just say nothing has changed. So order doesn't matter, repeats are not allowed. Therefore, this is 10 choose 4, or 10 choose 4 elements. Again, for practice, let's multiply that, or let's find that precisely. I do want you to get practice just simplifying factorials. So this is 10 factorial over 10 minus 4 factorial times 4 factorial. That's 10 times 9 times 8 times 7 times blah, blah, blah. But we're not going to worry about what's remaining too much because that's just 6 factorial. 10 minus 4 is 6 factorial. And so our 6 factorial cancels with this. Now this is 4 times 3 times 2 times 1. And so what else can we cancel? We can also cancel 4 and 2 with 8. And we can cancel 3 with most of 9. And so what we're left with is 10 times 3 times 7. 3 times 7 is 21. So we're left with 210 different subsets of size 4 from a set with 10 elements. Lastly, if a coin is tossed 10 times, how many different sequences of heads and tails are possible? And remember, sequences always means ordered. So does order matter? Yes. Are repeats possible? Yes. We can get a head twice or get a tail twice, etc. So we could either use the multiplication rule here or, our formulas above. Because order matters and repeats are allowed, that means that this is going to be n to the k. What is n? N is what we're selecting from. N is 2. In each trial, we have 2 possible outcomes. So this is 2 to the, we're selecting k times 2 to the 10th. Or we could just think about the multiplication rule. There are 2 choices for the first toss, and 2 choices for the second, and 2 choices for the third, and so on, down to 2 choices for the 10th, and this would also give us 2 to the 10th, which is 1,024.